Good, I hope. Okay, today I want to talk about behaviour-driven development in the broader sense of the word. Behaviour-driven development in both from the requirements point of view, right down to the actual TDD, low-level, test-driven development level. My name's John Smart. I work in Sydney, Australia. I do a lot of work in the test automation space, in the test-driven development, behaviour-driven development, acceptance test-driven development, and continuous integration, continuous delivery, all the technical side of agile, not the wishy-washy fluffy stuff. And today I'm going to be talking about behaviour-driven development, which is one of my pet favourite topics at the moment. It's something I think is a real game changer, a revolutionary way of developing. I think it really does have huge impact on the development process. And so I think it is really worthwhile spending that time to understand what it's about and to implement it, have a go, try and get it into place and see what the benefits are. The benefits are actually pretty huge. So I've seen some recent studies show things like not only the more obvious benefits of less bugs. So I've seen studies talking about 75% less bugs, so 4 times less bugs. I've anecdotally heard teams where it's 0 bugs in production once they start doing this sort of stuff. So mileage will vary, but the benefits can be huge. And also, despite the fact that you spend more time actually writing tests, if you're doing behaviour-driven development, and we'll see the related activities like acceptance test-driven development, you actually have a more focused development practice, which ends up delivering more precise code. You end up getting delivering faster, despite the fact that you write more code. And I have actually seen figures on that, up to 30% faster delivery, which I think is quite impressive. I was impressed anyway. So the benefits are there, and the benefits are significant. So what is behaviour-driven? Who knows what behaviour-driven development is about? Who does not know? Cool. Who doesn't know if they know or they don't know? The rest. Okay. So behaviour-driven development. Who knows what test-driven development is about? Cool. One of the things I've noticed, just seeing people coding at DevOps and in hackathons and hackagartens and demos, is that the test-driven development approach is becoming the standard normal way, at least, of showing how to code. So that's quite positive. Behaviour-driven development is an extension, a broader application of some of the principles behind test-driven development, but it takes it a little bit further. So one of the big things that comes across in behaviour-driven development is this concept of a common language. So who's heard of domain-driven development? Lots of 3-word acronyms. Domain-driven development, you have this idea of like ubiquitous vocabulary, where if you talk about a customer with the business, and you talk about a customer at the domain level as well, you don't talk about a person or a client or something else. So you have the same vocabulary going right through the system, and that's very good from a communication point of view, because it makes sure everybody is on the same page and understands what you're talking about. So in behaviour-driven development, you take that idea that specifications will be expressed in a certain manner by the BAs. They will be taken right through the system, down to the coding, up to the testing, and you'll have the same vocabulary used at every stage. So the BAs will see what they expressed as the requirements coming out in the tests that validate the system. So I don't actually talk about tests. In BDD, you tend not to talk about tests. You don't test your code in BDD. You write specifications. So you write specifications which are actually automated. So if you test something, it's already written. So one of the advantages of TDD is you get away from the concept that you write tests after you write the code. Because when you write tests after you write the code, what are you testing? You're testing that the code does what the code does. But you're not testing whether the code actually does what it's supposed to do. So the code may well do what it does very well, and you can verify that the code does what the code does. Unfortunately, the code may not do what it's supposed to do. So it may still be broken. So the idea of executable specifications is taking that concept in TDD where a little bit further, where you define what you think the application should do up front, and you express it in a way that can be automated and verified automatically. So you get specifications written in business terms, which then can be automated and executed every build and verified so that everyone can see whether the application is actually doing what the BAs and the testers decided that it was supposed to do. So that's really valuable. It's valuable from a documentation point of view as well, because effectively what you are doing is describing what your application does and how it does it, and then proving that it actually does what you say it does. When you take this approach, so you've got your specifications, you express them in a way that can be verified automatically, and then another benefit of this approach is that because you have these specifications that are automated, you know, with test-driven development, the principle is that every line of code must relate to a test. Every line of code is written to make a test pass. We'll extend that to specifications and imagine what you get. Every line of your application is written to implement a specification, implement some verifiable test, for lack of a better term, verifiable specification criteria that you're defined right up the start. So at any point in time, you know what you are coding, not just at a micro level, not just a local level, but at a broader application level. You know why you're writing your code. So this is a concept, some people refer to it as feature injection. You take your requirements and you drive the features that you need for your application out of the requirements. We'll have a look at how that works shortly. So because of this, every line of code you write goes back to a requirement, but you take it further with BDD. Every line of code is there to provide value for the business. So an application has a purpose in life. As a rule, it will be to provide value for the business of some kind. And when you express this, when you model this from the requirements all the way down, you can arbitrate to know whether a feature is really going to provide value for the business. You can define your requirements in such a way that the specifications give you a context. And that context can help you understand whether a feature is actually going to be useful or not. It's all very abstract. Hands up if it's too abstract. A couple of people are honest. So, in summary, the general reason why you might want to do BDD. It ties in with lean development as well. You're talking about reducing waste. So you're talking about writing code, building an application, building features that you know will provide value, and you have a traceability back to the value that each feature will provide. So there's a lot less wasted effort, which is always nice to be coding something that will be useful as opposed to coding to something that will never be executed. And that actually happens more often than you'd think. All about communication as well. So if your specifications will end up in the test results in exactly the same language as the business asked for, it makes it much easier to say, yes, we have delivered this feature. Here's our report that demonstrates how this feature works. And almost as a side effect, you get this test, this suite of regression tests which improves quality, but it's also about improving communication, and the benefits of the improved quality come from the developers having a better understanding of why they're implementing a particular feature. So I want to break this talk into two parts. First part is related to this requirement side of thing, which I think is very compelling. How you apply BDD to requirements analysis, how that ties in with the whole development process, and how it improves communication and improves the result, the end result. The second part of the talk will be taking, once you have your requirements, pushing down and getting to the code and having a look at some BDD tools at the code level. So you'll see BDD is actually used right across the spectrum of the development process, right from the requirements down to the code. So just getting back to the requirements, a typical application will be built with a few goals in mind as a rule. If you don't have a goal for your application, you probably will have trouble developing something useful. If you don't know where you're going, you may have trouble getting there. When you build your application, you're going to have features, capabilities, epics, whatever you want to call them, a certain requirements that you need to deliver. So often you'll organise these in a structured way. You'll have epics or features or capabilities at a high level. A capability will require its features to work. You'll come up with examples of how these features might work in the real world. You'll group them into stories. And then you will formalise these examples into acceptance criteria. Now the trick is if you can automate those acceptance criteria and have the traceability right back to the features and the capabilities and therefore to the goals, you get the same sort of justification for each line of code at a requirements level as you do when you're applying TDD at the coding level. So that's really useful. The trick, of course, is that you need to have that traceability. You need to be able to say, okay, this is an example. This is an acceptance criteria. It is used for this feature, which is part of this capability. Otherwise, you get a list of 100 stories or acceptance criteria or whatever, just randomly or placed in a single directory, and there won't be any organisation. You will have trouble knowing what stories are associated with particular features. It makes it harder to justify why you're doing something, and it makes it harder to report on where you're at with regard to different parts of the application. We'll have a look at how we can work with that shortly. So, since he says behaviour-driven development is very focused on examples, I'm going to start with an example. So, back a bit, here we go. So, we have a vision. This is loosely based on a real-world example. Customer wants to create an online classifieds website. It's a big newspaper corporation. Their first idea was brilliant. Let people place newspaper ads through the web. Then they had this really brilliant idea. Obviously no one had ever thought of it before. Why don't you put the classified ads online? It was a brilliant idea. I mean, it's totally original. Anyway, this was the plan. They want to build a classified website so that people could put their classified ads and do it through the web. So, that's your vision. You're going to have need goals to support that vision. Now, goals are usually to do with value. Goals are to do with increasing revenue, decreasing costs, or protecting revenue as a rule. So, goals are always about some money, unless you're in a government organisation, in which case they are about reducing costs. There are some other goals in government organisations, but the ones that you hear most often are reducing costs, nowadays anyway. So here we have a goal: increase advertising revenue by letting sellers post their classified ads online. And now, what sort of features might you want to deliver that goal? So, to make it easier for the people to post their ads online, you want to make it easier for people who post their ads online to sell the products, so you want to make it easier for the buyers to find the stuff they're interested in. So you might need a search feature, search facility. That's an example. So as I was saying, all of your goals, if a goal does not increase revenue, reduce costs, avoid future costs, or protect revenue, they're the main categories. If your goal is not in one of those categories, somehow, if it doesn't map back to one of those categories in one way or another, it's probably going to be hard to justify it. These are the sort of things that high-level executives think in terms of. Can anyone come up with an example of the goal of the application they're working on at the moment that does not fall into one of these categories? I'm not saying they don't exist, I'm just saying I have trouble thinking of them. And most examples that I come up with tend to fall back into one of those examples. Can anyone give me a counter example? No? Sorry? What? Increased profit would be increased revenue? Increase warm, fuzzy feeling when you go onto a website? Generally, there is an ulterior motivation of increasing revenue or reducing costs somewhere. Otherwise, you wonder why you're doing something. But when you are, with the exception of executives tend to think in these high-level terms a lot of the time, good ones. But if you ask a customer, they don't express their requirements in these terms. They're a little bit more pragmatic, I'd say. They'll give you solutions. Yeah? Has anyone come across this? Yeah. So the customer will ask for a specific feature which is in fact a solution. So one thing you typically do in a BDD approach, actually it's not just BDD, but what's very prevalent in BDD style approaches is you have to try and backtrack to figure out what the actual value proposition of the feature they are asking for is. Because usually they don't really know what they want. They just come up with a feature that they think would serve their purposes, but what you really need to understand is what their purpose is. So you just have to keep asking why do they want a particular feature. So here we've got users wanting to be able to search by keywords. So you get back to eventually to say that it's about the sellers. Oh yeah, okay. No, it's not actually about the sellers, it's about us, so that we can they can sell stuff on our site. And oh yes, it is about so we can earn money when they sell their stuff on our site. So you keep working back, getting to the original value proposition, and that gives you a really useful context when you're implementing features. If you don't have that context, you might think it's all about the user. Well, it's not actually all about the user, it's all about making the sellers sell their stuff online more effectively so that they can provide more revenue to the organisation. So it's very important to try and get context for any feature that you're asked to deliver and push back so that you can have a more precise idea of what you're actually doing and why you're doing it. So that is really important, because often when you do that, you end up with a solution which is different to the one the users will have asked for, but that is actually superior. So user, especially with user experience, with modern graphical interfaces and whatnot, you can do a lot more than a typical user coming from a 90s style website might expect. So you can propose solutions which are a lot more innovative and a lot more effective to provide value to your users than what the users might think, or not. If you have that context, then you're in a position to be able to judge. So, going down the stack, we've got our goal, we come up with our features. We want to know what a feature is going to deliver, why we want to deliver it. So we'll come up with some features or requirements, try and figure out what will actually support the goals that we're trying to deliver. So typically this will take the form of a backlog of story cards, for example. So you might come up with some stories or higher level features if it's a bigger application. And then you're going to think, okay, these particular features at the start of a sprint, what are we going to do? And what you'll have to think about is, I've got these 3 or 4 features that I can implement. What is going to provide value to the business in the next 3 or 4 weeks? Based on the context that I know, based on if I know where the user is coming from when they ask for this requirement, I'll be in a better position to say, okay, this search for online ads is probably more useful than notifying potential buyers about new items. Amazon does that a lot. You buy a book on cooking, which is a present for your sister-in-law, and Amazon will bombard you with books about cooking because you are now a registered cooking fan. Anyway, that's a side story. So you need to, when you're coming up with features, you need to be able to evaluate the relative value of the features that you're going to implement so that you can decide which ones you want to implement first. There are common cases. A government or big government organisation in Australia recently ran into a little bit of trouble with a large contracting company, payroll project that after 2 years and several $1 billion never actually managed to pay anyone. That's a little bit embarrassing for a payroll application. You'd think the primary value of a payroll application would be to actually put money into employees' accounts, but apparently not. There must have been other priorities. So the aim of this approach is to try and flush out the features that you need to implement to deliver value in the most possible value in the fastest possible time. So at any point in time, you'll have a list of features that you think you're going to implement, and you will judge by the context, going back to your goals, you will judge the context of what's going to actually be delivered. So you get down to your story level. So I typically use, this is fairly typical for BDD approaches, use the in order to do something as someone I want to have a feature. The reason the in order to comes first is rather than the traditional as is that it gives more focus on the value that you're trying to provide rather than who is it actually for. If you're just talking about who it's for, you tend to get shopping lists, just lists of features that people might like. If you say, okay, in order to increase sales, then the person who asked for it is almost irrelevant. It's the value, you're focusing on the value. So from there, you're going to come up with concrete examples of how your application might deliver these features, these stories. So here we use concrete values. It might be in the given when then format. Or sometimes you also might have a tabular format where you get a summary of several different edge cases or conditions, so that can make it a little bit easier to understand the context. So both approaches are fairly common. The acceptance criteria are written in high-level business terms. They're not scripts, they're business goals. When they're done well, they are a really effective way of communicating between the testers, the BAs, and the developers. And typically, you don't elaborate these. That's not a BA that does it. It's a BA plus a tester plus a developer, at least, and sometimes other people as well. So you come up with these concrete examples either as a table or as a given when then structure, and then you go and organise them. You're going to automate them. But when you're doing this, it is important to give it some context. So typically you'll store your requirements somewhere, so it might be in Jira, it might be in Rally, lots of different places. You need to be able to organise them in a way so that you can actually provide effective reporting. So we'll have a look at some examples of how that works later on. So here, a very basic approach. You've got a file structure, so rather than having your story files, your examples, just in one single file, you have them structured by capability, feature, and then story. And at each level, you give a context of what that feature is about. So in order to, as I want, type expression, which gives you the context. So at any point you have the context, and then you work down or work up to figure out what you're actually delivering. So that's an example, just with a file-based structure, but you would do that if you're using Jira. You configure your reporting to work with Jira. If it's Rally, it'll work with Rally. Whatever you're using, you're going to hook it into whatever you're reporting so that you have that structure. That is really important to get the sort of reporting you need for this sort of approach. So, enough of this requirement stuff. Let's have a look at some code. So, I'm going to look at two types of code. Here I'm going to show you a few tools that are around that help you automate these requirements, and then we'll look at the more low-level TDD style tools as well after that. So, first one I'll just go through quickly is JBehave. So JBehave is one of the first BDD tools from the Java world, so written by Dan North originally, who came up with the idea of BDD. So in JBehave, you have .story files which contain an optional narrative. I always put the narrative because it gives this context which I'm sort of emphasizing is so valuable. And then you have these scenarios. The scenarios are your examples. And there you have the given, when, thens. So how does that work? It's just a text file. You can also have tables. So here we've got a table with a set of examples that are injected into the given, when, then. So these are just text files. Theoretically, your BA can actually write these. In practice, the syntax can be, it's not syntax as such, but getting the quotes right and the variables and stuff like that. You'd usually have a developer who actually puts them into the version control system. But the text, the words, come from the BAs, a collaboration from the BAs and the testers. So how does that work in practice? You start off with this .story file, which again, just raw text. And then you automate it as in a Java class, or Java or Groovy, or it's JVM, so you can do whatever you want. You automate them with these given, when, then annotations. So just aside, the trick here is to keep it very high level so that they will be maintainable. If you're doing a web application, you don't want to start talking about fields and buttons here. You want to keep it focused on the business goals. So then in classic JBehave, you have a lot of options to configure the reporting and how all the configuration and stuff like that. We'll see, I usually use Thucydides, which is a BDD tool that I'll demonstrate later on. In that case, you just have a one-line class to basically execute all of your JBehave stories. So that's what a JBehave configuration looks like. There's also another well-known BDD tool called Cucumber, which comes from the Ruby world and is very, very similar to JBehave. So it's the same thing, you've got a feature rather than a story, but it's the same concept. And you've got your scenarios. And the same thing, you can have the actual syntax for the text files is almost identical. Then you implement it, again with Java code, so the implementation's a little bit different to the way they do it in JBehave, but it's the same sort of idea. You have a runner, and then you have very similar concepts, like given, when, then annotations, except in JBehave it's regular expressions rather than variable names. But it is very, very similar. So, third tool, which is an interesting one, is EasyB. So EasyB comes from the Groovy world. The interesting thing about EasyB is that the requirements are not a raw text file, they are actually a Groovy DSL, hence the curly brackets and commas and things. So the advantage of EasyB is that the implementation of the acceptance criteria is in the same file as the specification. The disadvantage of EasyB is that the implementation of the acceptance criteria is in the same file as the specification. So the advantage is obviously it's all in one place, but the disadvantage is you lose readability because you have implementation mixed in with what you're specifying. I tend to use, I've used EasyB quite a lot in the past. I tend to use JBehave nowadays because I find it easier to communicate with the business without worrying about the implementation details unless I really want to. The fourth tool I want to talk about is Thucydides, which is an open source tool which helps you organize and report on the requirements being executed by these other tools. So you'll start off with a scenario. Thucydides will observe when you execute the scenario and will produce structured reports on the results. It also helps you structure the implementation. So as I said here, at the highest level, we only have 1 or 2 lines per given when then because that's intentional. It makes the test a lot more stable. That's the business process. That's not going to change a lot. Then we'll drill down into the details. What happens when you choose your region? Where you're on the home page, you choose a region. On the home page, you'll choose a category and then you'll enter some keywords. So how you do implement a test, how you demonstrate that the application does something is one layer down from what you're trying to do. So that is very important if you want your test to be maintainable. And then that produces reports which help you categorize these requirements. Remember I said we have our capabilities, our features, our stories. It's important to be able to report on individual parts, on how the acceptance criteria are going for a particular feature, a particular capability. A test report in itself is not good enough. A test report will tell you how well the tests are doing. A test report will not tell you if a feature has no tests at all. So the idea of Thucydides is to map into this concept of, to map into the requirements that you define somewhere and report not only on what tests have been executed, but also on what tests have not been executed. So that's very important, trying to keep track of things. So then you, as you can see in the slides, you can go through capabilities, drill down into stories, and then actually demonstrate to someone how the application proved, how the test proved that the application does what you say it will do. So one concept in acceptance test-driven development and BDD is the concept of living documentation. So documentation that you don't have to update manually all the time. Documentation that you know is up to date, because if it's not, the test will break. So this is living documentation. For each requirement, you know where it comes from, because you have the context, what feature it's in, what capability and so forth, and you know how it works, how it demonstrates that the application does what you say it will do. So if it's a web application, you get a sequence of screenshots and so forth, or you just get a sequence of steps. Now saying, okay, to prove that the application does this, we did this and this and this. So if you're in an organisation where there are audits, this is very useful, because to demonstrate that your application is tested, you just zip up the Thucydides report and give it to the auditor. It's also good for new people coming onto the team. They can understand what the application does, what it's supposed to be doing, and how it does it. So the other aspect that I wanted to cover today is how BDD applies at a more tactical level, a more low level, when you're actually day-to-day coding. So BDD is not only about requirements, so that's a really important part of it, but BDD is also about coding. So it's a strong relationship between test-driven development and behaviour-driven development. So test-driven development can be considered a precursor to behaviour-driven development, or behaviour-driven development can be considered a style of test-driven development, which expands out into the requirements definition as well. But we'll look at some of the tools. There are specialised tools that make doing test-driven development in a BDD style very easy and very compelling. So essentially, TDD is about figuring out what test, or how to make a test work. So you have a requirement, a test that you want to write. You write the failing test, you make it work, and so forth. It's very small, tight cycles. But how do you know what test you're going to write? Here, you're going to use the high-level BDD, or acceptance test-driven development, come up with your acceptance tests, and then expand out, drill down, and figure out what you need to make an acceptance test work. So your high-level at the lowest level, you're going to have tools like a JUnit or Spock or Aquilian. The higher level, you're going to have tools like JBehave, EasyB, Fitness. There is a little bit of a mix. Sometimes you'll have Aquilian as well at the higher level. But generally, you have these two levels. You have tests that will tell you what features you're supposed to implement, and then at a TD level, how do you actually implement them? How do you write the code to make that work? So what do you want to do? And then take that down a level, how do you do it? So we'll come up with our high-level requirements. We'll have our goals, we'll get down to our stories, we'll get down to our scenarios. And then, how do you make a scenario work? Well, it's going to need a UI maybe. You get someone will come in, a designer will mock out a UI. Then how do you do the UI? Well, we need to list a list of clients. Okay, how do we list a client? Well, we need a client. So we need to be able to have a service that calls a database that gets a client. So how do we make that work? So you push out the features you need to implement from the acceptance criteria. So there is a distinct difference in style and in the approaches of acceptance tests, which are much more focused on communicating and guiding the development process, and unit tests, which are much lower level and more about getting the code working. So let's have a look at a few low-level BDD tools. My personal favourite is Spock. Who's used Spock? A few people. Spock is what I use for all my TDD work. I've been weaning off JUnit and moving over to Spock for a while now. Spock is really much more lightweight and compelling. I used to have a good reason not to use Groovy in unit tests, and then I gave up and just thought it was just too easy. The good reason is that examples of code in your unit tests should be in the same language as the code that actually manipulates them, because they are examples of how to use an API. But Groovy is close enough to Java for that to work anyway. So here's an example. Nice thing about Spock is it's not just a test and then you do some stuff. You have this structured approach where you have the given, when, then structure in the code itself. So given we're selling a shirt, how's that work? Well, we've got a sale object, then we calculate the price including GST, so we get the total price, then the total price should be equal to 11. And just say total, you don't even need any asserts or assert that or whatever, you just say total price equals 11 and you're done. So if that fails, the error message is clear enough for you to know what's going on immediately. It'll tell you what comes on both sides. That's Groovy. That's one of the nice things about Groovy. Groovy does that. So it's both very concise and clear, but the reporting is also sufficient enough to be able to troubleshoot any errors. You can also, so if you've done any work with TDD, you'll be familiar with mocking tools, like JMock, Makito, things like that. In Spock, it's very easy to do this sort of mocking. So this first example that we've got here, we've mocked out a GST rate provider, and we're saying it should return 0.125. Here we've got another example where checking that if we make a sale, then the delivery service dispatch method should have been called at least once. Or once, exactly once. So there's a lot more stuff you can do with the mocking in Spock, but in a nutshell, that sort of explains how concise and effective it is. When you get used to it, it is a really very nice, lightweight way of coding your mocks. And you can also do data-driven tests, so table-based tests. So you can do this in JUnit, but it is a bit of a pain. It does feel very much like putting a square peg into a round hole. In Spock, it feels very natural. So what have we got here? When I find a plural form of a single word, then the plural form should be grammatically correct, where, and then I give the examples. And so that makes it very easy to add new examples or do corner cases. And you can put, rather than in JUnit, you have to have a whole test case dedicated to data-driven tests. In Spock, you can have as many specifications, as they call them in Spock, with different tables of data. And you can also use Spock for integration tests. You can integrate Spock with Archillion, which is a tool for doing basically lightweight integration tests. It will take the classes you need to use, the EasyBs or the whatever you're using, deploy it to an embedded application server, and then run your unit tests, or actually integration tests. And so it's not a lot of overhead, as you can see here, doing integration testing in a BDD style as well. So you really can apply this technique right across the board. If you were to ask me what BDD tool should I use for my Java applications today, and you don't know anything fancy, then have a go at Spock. Spock's very cool. On the other hand, if you're a Scala fan, there are some very nice BDD tools in the Scala world too. So this is just one of them, spec tool. It looks very similar to Groovy, the Spock, except instead of a Groovy syntax, you have a more Scala-style syntax. But effectively, it is quite similar. You still get that same given, when, then structure with the asserts and whatnot. Very lightweight, very efficient. You also get similar lightweight mocking and stubbing. So this is an example. The mocking DSL in Spec Tool is quite interesting, actually. It's here we've got the sales example from earlier on. So we've got a mock GST provider and a mock delivery service. When we make a sale, then we expect that there was one sales delivery service dispatch of any string. So it's very readable. So one of the things about these newer BDD development tools is that they do make life very easy from a developer point of view to apply these techniques. It doesn't take long to get used to them, and you can do really lightweight, fast, efficient tests. Get a lot of power out of your unit testing. So you get a similar sort of data-driven table base that we saw earlier on. Again, the syntax is more Scala-ish than Groovy-ish, but the idea is very similar. So last tool I want to show you is Jasmine. Jasmine is a JavaScript BDD tool. So my thought when I heard about this was if BDD is being used in JavaScript, then it really is being used everywhere. So if you're testing your JavaScript functions, you can use Jasmine to express your requirements in a much more readable manner. So using nested functions and whatnot. So here we've got an example of a temperature converter. So it converts Fahrenheit to Celsius, and expect that converts 50 Fahrenheit to whatever Celsius. So again, if you're used to JavaScript, the syntax is not a problem. It is the nice thing about Jasmine, if you're doing any JavaScript, there wasn't much in the way of unit testing for JavaScript until quite recently. And this is a really nice way. So you can even do hierarchical, group your requirements into in a sort of more structured way, do nested behaviors. You get, you don't just have equals, you can have things like whether a variable is defined, whether it's true or false, to be less than, greater than, and so forth, contains. So you get a lot of value, a lot of power in the in what you can test. Also integrates with Maven, which is quite nice. So you can run your JavaScript tests in Maven and make your JavaScript tests part of the build process. So you can actually do TDD on your JavaScript functions and have it integrated into Jenkins and reporting, just like any of the other tests. So I guess the point of all of this is just to show you how pervasive BDD is. It really is something that applies right from the specification level right down to the coding level. And it is very useful at all levels, so to different degrees. From the specifications level, you're guiding the development process, you're focusing the activity, you're reducing waste, you're making sure people are actually delivering value. At the coding level, you're writing specifications, you're ensuring very high quality code, very high coverage, all the advantages of TDD, plus documentation. So if you write your Spock, for example, you write Spock, you're effectively writing specifications for your API, so you're documenting your code in a way that's infinitely more powerful than Javadoc comments ever were. And I think that's really compelling. So that's all I had to say on BDD, so now we'll open the floor. We have 9 minutes left for questions. Yes? I'll repeat the question unless there's a microphone going around the place.
Yeah, has the combination of Jasmine and Maven improved? Because a few months ago, with a colleague who actually now settled down not far from where you're from, we had some challenges, so actually we had to abandon Jasmine and then use something that does more or less the same thing, but integrated better with Maven. Have you seen any troubles in the...
I didn't have any troubles running the tests that I was using for the demo, and that was maybe a month ago, just before Java 1.
So you haven't...
I haven't tried it.
You haven't followed that in earlier months or years?
No.
Okay.
Any other questions? Okay, well, thank you.